Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the functional group present in the structure. The molecule shown is a 6-membered cyclic structure, tetrahydropyrin ring, where the ring oxygen is at the top. The carbon directly bonded to this ring oxygen, the anomeric carbon, C2, carries both an OH group and an H atom. Moving on to the next step. A hemiacetal is formed when one equivalent of an alcohol adds to an aldehyde or ketone. It has the general structure RCH, OH, or where one oxygen is part of an OH group and the other oxygen is an ether-type oxygen. In cyclic form, a hemiacetal arises from intramolecular cyclization of a hydroxyaldehyde. The hydroxyl oxygen becomes the ring ether oxygen, and the former carbonyl carbon now bears both O and H from the original aldehyde hydrogen, fitting exactly the structure shown. Moving on to the next step. The shown structure has an ether oxygen in the ring, one O bonded to 2 carbons. The carbon at the ring oxygen junction bearing O and H. This is precisely the cyclic hemiacetal pattern, C bonded to O, ring O, H, and one more carbon. And for the final step, acetal, an acetal has 2 OR groups on the same carbon, RCH, or 2 no free O. The structure has only one ether oxygen in the ring, plus a free O, so it is not an acetal. C. Hydrate. Gemdiol. A hydrate has 2 OH groups on the same carbon, RCH, O2. The structure has one OH and one ether oxygen, not 2 OH groups. D. Cyanohydrin. A cyanohydrin has an OH and a CN on the same carbon. No nitrile group is present. Therefore, the correct answer is B. Therefore, the correct answer is option B.